So hello everyone, this is a follow-up of the latest video that I made about the powers of digits in a calculator. So in here I've summed up all the 9 digits and how they actually go. So for example for 2, we have 2 times 2 equals 4, 4 times 2 equals 8, 8 times 2 equals 16, we take the 6, and then it goes back to 2 and it goes round. So for 3 we have 9, 7, 1, and it goes this way, and for 8 and 7 with 4 and 9 we have these values. So for 1 and 5 and 6 it doesn't move, they just stay at their own digits. So I want to see if I can increase the number of digits. So for example here we have a base 10 system. What if we go to a base 17 system with 16 digits on a bigger calculator, for example? So if we go ahead and change that, so I'm gonna change the value from 10 to 17. And so we get actually these values. So these diagrams. So we have, for example, for 2 we have a square, for 4 as well, and we have these more interesting patterns that we see. They are all like symmetric with 90 degrees, which is quite strange because why would this be? So we have a kind of symmetry. We have a cyclic pattern, but we also have a symmetry. I can also remove the text so we can see better. So we can see that we have these beautiful patterns that arise. And then when we are in bigger, we take a bigger calculator. So in here we have base 26. We have even more interesting patterns. So what's going on here? We have these beautiful cyclic patterns, and we see that some of them repeat, but they are actually opposite of each other, so their direction are changed. So 11 and 19 have the same pattern, and we have, for example, 7 and 15 with the same pattern, 5 and 21, 4 and 10, 17 and 23, 16 and 22, etc., etc. So there is a nice pattern going on here. So we can say that, for example, 16 and 22 are duals, 11 and 19 are also duals. So let's go up and see what new patterns we get. So we have, for example, base 37, a grid of 6 by 6. And we start seeing that these patterns, some of them are not regular anymore. So for example, 12 and 9, they are not symmetric with respect to 90 degrees. But still some of them are. Some of them are also symmetric to 180 degrees. Let's go to a higher base. Yep, so we see even more and more beautiful patterns, and it's quite interesting things. So we also see that we have on the corners, we have squares. So I don't know if you noticed before, we always had squares on the corners, on the top left and bottom right corners. We had some squares, and yeah, so we have these duals again, and these duals are not symmetric with respect to the center, for example, for 25. They just happen to be dual, but not really organized in a kind of symmetric way in the whole diagram group. So yeah, let's go up to base 65. Yep, so we still see more and more patterns. Some of them are irregular, and we see this square. So 8 times 8 equals 64. 64 times 8 base 65 equals 57, and then 57 times 8 base 65 is 1, and then it goes round and round. So we have always these square patterns. For the 2, it actually follows up the 8 pattern, but in 3 steps instead of 1. For 4, it goes to 16, etc. So, so if you have any idea of what's going on in here, you can actually comment in the video. And I also added the code in the description. I put a link description below. So, so we have this kind of symmetry, but we know that it can be cyclic because eventually you can go back to any given number that you've been before, and then you just repeat the cycle. But why is it symmetric? Why is it 180 degrees symmetric or 90 degrees symmetric? That's quite an interesting question. Let's go up to a bigger base, so 82. So we see even more and more intricate and more complex. This, for example, this one is quite beautiful. We have a 5, we have a rose type, and then we have also other kind of more symmetric, but still beautiful patterns. Then let's go to 101. Now it starts becoming a bit more difficult to see, but it's quite interesting. So we have all these patterns, and so this 46, for example, is going all over the place. It's quite funny. But yeah, so if you have any ideas of what's going on, I've put a code in the description, and it's in MATLAB code actually. I'm sure someone will find out a way to make it in Python. So let me know what you think. Thank you very much for watching the video.